Have you ever wondered how to develop a Google Chrome extension? Well, you'll find out in this video. So in this video we are going to show the most fundamental concepts of Google Chrome extensions or Chromium extensions. They work with all Chromium-based browsers, so also for Edge and Vivaldi and Brave and Opera. So they are all the same. This extension will allow us to show how to actually shape your development process, what's the file structure of an actual extension, how to do the development at all, and in this particular case, by integrating at the bottom of every web page we're loading, we'll be integrating this picture here. This picture comes dynamically from the NASA Astronomy Picture of the Day API. So of course it's every day a different picture. And no matter which tab we'll open and which web page we are surfing to, it will append this picture to the bottom. So this way we are able to show the development process, the file structure, the messaging throughout the extension from the service worker to the front ends. We'll explain what actually is the service worker, what are the front ends, and we'll show how to integrate very basic API data and how to do the DOM manipulation within the content of a tab. So let's go. So throughout this series, I'm going to use Visual Studio Code. It's a good solution. If you want to use something else, of course you can do, but this really doesn't matter for the extension development itself. We have a new folder, so we'll create a new folder. This folder in my case is called My Extension. And there is already a subfolder, as you can see, so subfolders are no problem. In this particular case, I have a subfolder called Images, and in there we have 4 image files. So those are basically icons. Chromium specifies 4 sizes that you can ship. So 128, 48, 32, and 16 by 16 pixels. So it's all the same file, just in different sizes, different dimensions. So that's nothing special here. So we'll create a new file, and the first file is going to be the most fundamental and most important one. So that's the manifest.json. We'll also create a file which will be our service worker, which is called the background.js. And we'll also need a foreground. So this basically is our front end. So think of the background as kind of the back end for the extension, the foreground kind of as the front end of the extension. It's not really precisely correct, but think of it this way. And then you have the manifest, which is the base configuration. This one gets parsed the moment you install the extension into the browser, and you need to declare a few items, otherwise the extension won't be loaded properly into the browser. So we start by filling out the manifest.json, and I've pretty much prepared a very basic version of this, and I will just walk you through all of these individual settings here. So it's a JSON file, so it starts with those brackets, and then you have key value pairs like a name, which in this case is demo extension, the description, which is this is my first extension. Then you need to specify a version. Of course, it makes sense to start with a very, very low version number and to iteratively and to increase the number with every release you're shipping. Then, very importantly, you need to specify the manifest version. So this manifest version, version 3 is the current version. This means we are in the 3rd generation of the extension architecture for Chromium-based browsers. It's pretty recent, so I think it's less than 2 years in production right now. And manifest version 2 extensions are no longer accepted in the Google Chrome store. So if you want to start a new extension, of course you use manifest version 3. Then you have those icons, which I just have shown you. So you specify those four values for 16, 32, 48, and 128 by 128 pixels. And here we are just pointing to the root directory of our extension, then to the folder images, and then those 4 file names. So nothing really special here. Then we set up the background. So the background actually is a service worker. This is a good word to Google for once you start running into trouble with your service worker. But actually in the manifest, it's the main key is background. Then there is an options page, so you can specify an option page, and I haven't created that folder yet, so I'll create a miscellaneous folder, and then within that folder I'll create an options.html page. So this needs to be there, otherwise our manifest JSON wouldn't be parsed correctly. So we have that, and then we need to set permissions. So permissions are permissions that the browser will grant this extension. So we want to access the active tab, we want to access the tabs collection. Later on, maybe we want to start using the local storage of the browser or synced cloud storage of the browser. We want to use but we definitely need to use scripting. Also for our small use case right now, we won't need alarms and notification at this point in time, so we can definitely remove that. That's no problem. Storage is also not needed currently. We could remove that as well. And then host permissions. This is the thing. You could specify that your extension only works on specific domains, in specific paths or subdomains, stuff like that. So you could actually reduce the host permissions. This key here, all URLs, basically tells the extension I want to access every URL, every tab, every domain, everything that is loaded into one tab, because we already have access to the tabs themselves. We're not reducing the scope by specifying domains or something, but you could. If your use case is valid for that, you should considering to do so. So first of all, I highly recommend to use browser profiles for your development process. I've created here one, I've called this 01 Fundamental Concepts, and you should actually, once you have finished to develop a feature, you should throw this browser profile away and create a new one, especially when working with browser storage or cookies, stuff like that. So where you could run into an issue which is not occurring in the browser you're doing the development in, but is actually happening on browsers which are doing a fresh installation. So make sure that you use browser profiles and to exchange them, get rid of the old one, create a new one, and test what you've done in a fresh browser profile. Then you go to more tools and extensions, and I will push this to the front here. And what you can see here is that we have this developer mode. I will just turn it on. And using the developer mode, now you have 3 buttons. The first one is load unpacked. The second one is pack extension, and then update. Pack extension, update are related to the Chrome store. I will just click on load unpacked. I prepared this, so we'll go to this my extension folder and where our extension lives. And as you can see, voila, we have the extension successfully imported. So our manifest.json was successfully parsed, and now this extension is part of the browser context. A few important things here. That's the name, that's the description, very easy. You get an ID here. This is important later. You don't need to write it down or copy paste it. There are programmatic ways to get this. As you can see here, you have the inspect views for the service worker, and this now toggled to inactive, as you've seen. So especially with manifest version 3, the service worker won't live forever. It won't be active forever. You need to make sure that it is actually active. And by just clicking on this inspection view here, so this link opens a new window, and typically it starts at first here, but of course you should look at the console most of the time. So now the service worker is again active. If you would wait long enough, then it would be again turned into inactive mode. You should leave this always open, because often it's not very clear where an error is happening. Is it happening in the background or the foreground? So just the recommendation is to just leave it open. And here you can use this toggle button here to reload the extension. This is needed if you are working on the background script on the service worker if you do changes there and save the file, those changes are not being respected in the browser context. You just need to reload it every time you have changed and saved your service worker, in our case the background.js script. And this way you make sure that your browser context has always the latest version of the service worker. Of course, you can remove it and you see details, a few things here, like permissions and site access, like we actually specified, and things like that. So now what we could do is click here on this puzzle icon, and then here is the demo extension, which we could use here. And then we have this thing pinned next to our actual browser. And when we go here, then you can see now that here it's actually in active mode. There's the icon is shown the correct way. Next thing is we can see that this extension, it's very nice when you have this mouse over, has access to the site. You remember we specified this all URLs, host permissions, that's why. And you can see here also a very interesting thing, that's the name. The user can of course interact with these settings here. And there is this options page. So we specified in the manifest.json our options HTML file located in this miscellaneous folder. And as you can see, our extension actually has a URL. This URL is derived from that ID, which you have also seen in the extension path here. It will change often, so there's no way to hard code this. You can get this URL programmatically, don't worry. But this is the options page. Of course, you can do other things with the interaction on the click of this icon. So you could create a pop-up file, for example. We'll do this later. So the first thing now we need to see is that our background should be working in the context of this particular tab, which actually has a website open. And here, by hovering over the icon, says, okay, the extension has access to this site, but how are we going to manipulate this site in order to show the NASA astronomy picture of the day picture down below? So we'll have to do some basic implementation first. So now in our background we have access to the chrome.runtime, and we can interact with that. And we also stated that we want to have access to the tabs collection. Of course, the tabs collection supports events. So there's an event that's called onUpdated. So if one of the tabs actually is updated, then also the tabs collection is updated. So this way we can recognize if one of the tabs actually was updated, and we can bind a listener to this particular event. Okay, so luckily this supports asynchronic context, and this takes a few arguments. So the first one will be the tab ID. The next one basically is the state of this tab, and the third one then is a tab object itself. We can use a simple arrow function to interact with this further. So again, tabs collection is updated, and we'll identify, okay, which tab was it? Who's the troublemaker? Okay. So the next thing, and I learned this pretty much the hard way, and I can only recommend to do better for you guys. So there are always occasions where there could be a runtime error for whatever reason. Maybe the device is out of memory, or there was something else wrong. In this particular case, it could be that this harms the experience of your extension, and you should just don't just try to avoid it. So just send a response message. If there's an error on the runtime, just send a response and you're done. The next thing you can actually do is you can create a console.log and see, okay, which tab actually was it? That's a simple thing we're going to do here. So I changed the service worker. I will now reload that service worker. I will go over here and then just say reload that page. And as you've seen, there have been 3 events firing. The first one here, you can see the structure a little bit. So you see things like the tab ID and the height, the width. You also see the URL and the title, and you can see the actual status. Second thing here is pretty much the same. I cannot spot the difference at first. So I guess the first event is basically this tab changed from complete into loading. So now the new state is loading. I don't get why there's a second time loading. Maybe it's still loading. And the third one here says status complete. And status complete is pretty much the state we're looking for when we try to push a front end for the extension into that tab. That's what we're going to do. So we'll use this event here to actually integrate this. So I'll move this. Let's say let's remove this thing. We'll create an if statement. So if state dot status actually is complete. This is the status we're looking for. That's one thing. And the second thing is, you might have also recognized earlier, our extension has access to this particular tab because this thing is HTTP. It's a simple website. It does not have access to this particular page because this is not of protocol HTTP. So it also wouldn't make sense in our scenario to have access to a tab which is loading FTP or something. So we want to make sure that this is actually HTTP. And yeah, the easiest way to actually check this is kind of the regex way to do it. So we'll check for the tab.url. If it is actually, I made a mistake there. Oh, this one is wrong. So that's correct. So that's the easiest way to do this. And if both conditions are true, we can then implement some functionality. Of course, you should now use, let's say, try catch. Let's, for the sake of completeness, also do this console.warn. So then we have actually the error, and now we can start to implement some functionality. As this thing is in an asynchronous context, we can benefit from that and just to use asynchronous. And here there is a interface on the Chrome runtime which is called Chrome scripting, and Chrome scripting has a functionality which is called execute script. This thing expects two arguments. The first thing is what's the target. So target actually in our case is a tab ID of tab ID. Could have named that more distinguishable, sorry for that. And the second thing now is a list of files. So this could be a list, and we are going to our root for the foreground.js file. So root, / foreground.js. Guess we need a comma there. And yeah, so this is the thing. So we are looking for if the state changed to complete and the tab URL is kind of HTTP, then we want to try to execute a script, and this execute script is targeting the actual tab ID, which just changed to complete, and is injecting the file, or is executing the file foreground.js. In foreground.js, I have prepared this console.log statement, console.log hello from foreground. So let's try if it works. So first thing is, again, I'll bring up the console for the background for the service worker, just in case something doesn't work. And if I now reload this, you can see, seems to be not working. Well, that's not true, because this here is the console log for our foreground. And in here, we have the console log from that particular page. And from this page, from the console log of this page, our foreground.js file, this is now part of this page context, is actually console logging something in here. So we have actually successfully injected our script into this tab, into the context, actual DOM of this tab. It's now in there, and now we could start to build some DOM manipulation from here. So messaging. Now we have our foreground script successfully injected into the context of that tab. And now we want to just, let me get a bit more space here. Let's push the foreground to the right side. I like that a little bit more, so we have more space and we can work in parallel a little bit. So the next thing is we have injected our script, and now we want to do some basic messaging. So again, we'll do this asynchronously. Chrome.tabs, and we'll send actually a message. And yeah, the method actually is, or the function is send message, and it requests us to specify the tab ID, and then we can actually provide more details. So the message, for example, is, let's say, we'll just set a message of the name this URL, and we'll also send a payload. I just specify a key, that's a payload, and we'll just send tab.url. So this is the URL of the current tab, and we'll just send this information to the page, to the foreground. So now the question is, okay, how does this foreground actually listen to messages from the backend? So it is not actually listening to messages from our backend, it is listening to messages from the Chrome runtime, because this interface here is actually sending messages over the Chrome runtime and not over a dedicated port kind of thingy like you would maybe expect. And so it's Chrome runtime.onMessage, and here we again can bind our own listener to this thing. So there is a request for this message. There's an actual sender, which in our case is our background, so we don't really need to do much about that. And maybe finally we want to send some response. Again, easy arrow function syntax here. So first thing, now what we could do is we could just do console.log the actual request and see what happens. So again, reload the extension and reload the page. And as you can see in our foreground, this message was actually successfully received. So there's the message with the name, this URL, and the payload, which is the URL of this current page. So that works absolutely fine. So now we can just say, okay, if, let's say, request dot message equals this URL, then we want to do something. And here again, it's it might not happen often, but if it happens, it's very hard to debug. I'll just again copy and paste this in here. So let's deal with errors if they happen. So it could be formatted nicer. Okay. So, and right now maybe we can just sorry for that. We could just console.log request.url, for example. Request dot payload dot let's say to string, although it already is a string. Let's say it doesn't hurt. And yeah, so this way now we haven't changed anything on the background script, so we can just reload this thing, and here we just have this output. So this is of course pretty easy. So as now the messaging works, the base messaging works, the question is, can we only communicate in one way? No, of course not. We can also communicate in other ways. So I will now just call a function, let's say apod, so get apod. I'll just specify a name. We'll create an async function. Because we'll do in the chain of processing, we'll do everything asynchronously, because the ultimate fetch call to the API we're going to use, of course, runs in an asynchronous context. And so it's important to have everything asynchronously, otherwise you run into trouble as well. A pod image takes no arguments. It's a pretty simple thing. And now we'll define, let's say this could be a const. Let's call it response, because that's the object where we are awaiting the response actually. So we'll use await chrome.runtime.send message. So this works the other way around as well. The funny thing here is that we only have one service worker, so it's pretty easy. I can just say fetch apod image. So apod stands for NASA Astronomy Picture of the Day. Astronomy Picture of the Day. So I've just specified this message. So this thing can basically only terminate on the service worker, and so this way we can communicate with our service worker. We can then, let's say, just do a console log of our response and see if that works. So now we are sending a message back here to the background. And here, as you can see, there is no message listener for any messaging thing. So we need to specify this. So chrome.runtime.onMessage will bind an event listener. Easy as that. Again, same signature as on the right side. So we'll have a request, a sender, and we'll send a response. And again, make life easy just using arrow functions. We can now state, okay, if let's say request dot message equals fetch apod image. So this is exactly this message we are sending. So if this is the message, we want to do something. Again, it's a good practice to do so. I could use a macro for that actually. And yeah, so we'll call a function. Of course, we could do this inline here, but actually it makes sense to separate business logic from this event listener. I find it way more intuitive and actually also cleaner to deal with these things. So first thing is we're gonna pass. We don't have payload right now. We could have, let's say, in some other use case, we could not only provide a message name, but also payload, like we have provided a payload here. And then we could pass, of course, this payload, let's say a user interaction, a data point the user set, a date picker the user has used. So provide a payload, which will then transport also to this function. So we'll pass the request over to this function, and then just say do a dot then send a response. Okay, and also return true. So all we need now is an async function, which actually is called getApodImage. It takes technically the argument. So again, this is still our request that we are passing over. And now we can, of course, also integrate our fancy runtime checker. And once we've done that, we can actually start to implement some code. So first thing, I will just copy and paste this. It's easier to see. So the good thing about this NASA Astronomy Picture of the Day API is that this thing actually has a demo key which is working. So we don't need to sign up for some service or something. And it's very easy to replicate for you guys. Next thing we could also then define is no headers. So we let's say new headers. So those are headers which we could pass to our fetch call, which we do right now. But yeah, in this particular case, we actually don't need one. but just for the sake of completeness. So again, here we are waiting for a response. So we'll do this wait, fetch, and now actually we have a few arguments. So the first thing is our API. So this is the API call, and then we can pass in a few more objects, a few more arguments. So first thing actually is we'll provide the method. In this case, it's get, straightforward. We could also deal with things like, for example, cores. This would be done here. We can do it right now. It doesn't really hurt anything. We could also specify a, let's say, content type in our request, which in this particular case actually makes sense, although I think it would still work otherwise as well. So we'll provide content type application JSON. So we'll send this in our fetch request. It's get, it's core, method is cores, and we are requesting for the content type application /JSON. And we could also provide our headers object, which we actually not really using in this particular case. So headers, and then we have this response. The funny thing with working with API data, especially with JSON data, is that this now needs to be casted to JSON. So I'll create a const, let's say I call it data. A short correction from the post-production. The issue here is not that we need to cast this JSON answer actually to JSON. The thing is, the fetch call actually is producing a stream, a data stream, and we need to make sure that the data stream actually is finished, and after it's finished, that this now is then actually treated as a JSON object. That's the main reason. Okay, and now I can actually return the data. So we have injected our front-end script. The front-end script is working. It's getting the message. The background is sending over here to the foreground. So it's fully working, and it can communicate with the backend. We could call a function here. This function is of asynchronous context. This thing will send a message, again also asynchronously, and will console log the response. This message is being retrieved here with this event listener to on message for the Chrome runtime in our background, in our service worker. This takes the request and passes this over to an async function. And this async function is now just specifying has this API URL, is doing this fetch call, is awaiting for the response. So that's the way this thing should be working. Let's see if it works. So we need to, because we changed the service worker, we need to reload the extension. And we should right now, let's see, bring also this console up here. If we reload the page, we now should expect to see the same thing here, because we haven't removed this. We have removed this console log. The first console log is here. The second console log with the URL is gone. Doesn't matter, not so important. We should see this hello from foreground, and also the API response as JSON data in our console log here in the foreground. This is what should be happening right now, and as you can see, this actually is working. So see, picture is of a globular star cluster Omega Centauri. Pretty nice, famous Omega Centauri. And you can also see we have a new image, not the one I showed you at the beginning of the video. So this is the current picture of the day. So this is the API response. So, and of course, if we just would use this demo key here in some browser, then this thing would happen here as well. Okay, so this is the API output, and the next thing we want to do is we want to take here somewhere is a URL to a picture. This is this HD URL, and we want to use this URL to actually append an image tag to the bottom of this HTML source code, and this is what we're going to do right now. So DOM manipulation. Of course, here we do have the response, and now we want to add this this div to the bottom of the page, and we also want to do maybe style the elements that we are bringing additionally to the page. So let's say we will do just the standard one, like for example, just name a div. Let's say div container, and we'll just say, okay, document dot create element, and this one is of type div. Okay, our div container maybe should have an ID, and SD is, let's say, my extension div container. So pretty extensive long name that we don't run into collisions. There's a whole different approach with, for example, shadow DOM. There's also other techniques you can use. That's definitely for some other video. Then we also say, okay, div container, class list, add. Let's say we'll have a class list that we want to maybe use, and let's say the class list will say my ext apod image, and then finally ultimately document.body.append child, and of course use our div container. So we right now would have added a div to the body of the document, just ultimately at the end. What we also would have in here is we have specified a class list. So, but we don't have CSS in here. How do we get CSS in here? Well, of course, we could have just, created and used all inline styles here. But of course, it makes sense, especially if you're planning to build a bigger extension, to also have CSS files. And CSS files can be injected into that foreground script, or into that context of that tab, the same way we can ingest actually the script itself. So we can use Chrome dot scripting, and there is a feature which is called Inject CSS, and this you can use to actually insert a CSS file. Again, we have to specify the target. Same thing as before. Tab ID is a tab ID, and of course, then there again goes the files. And in this particular case, we don't have any yet, so I'll create a folder. This again also is a good practice to put, for example, CSS files in a folder, so you can leverage that. So same thing here. So what we would need to do right now is to create this CSS folder, and then also create this new file, foreground.css, and here we go. And of course, now we have said, okay, this is my export image. Let's say dot. Sorry. This keyboard kind of is weird sometimes. So, and let's say do some basic stuff. Flex. Let's give it a min height so that we can already see it. Min width. Let's say 100%, and let's specify a background color. Let's take violet. So this way we should now have injected, using the background, injected a CSS file which we just created. There's just this class in here. We've also added this this div to this particular page. Let's see if this works, how this works. So need to reload, as we again have changed the service worker, need to reload that. no errors there. Let's just click on reload. We still get the answer from the NASA APOD API, and as you can see, here's our ID, our div with our ID and the CSS class. And as you can see from this injected style sheet, here you have our style information. So having that said, let's just go ahead and append the image to this particular thing. So let's say that apod image is document.create element, and this one will be of type image, apod image.ssc is, and here we go, it's request. Let's see what's the actual image. It's request.hdurl, request.hdurl, and to make life easy, we'll just say, okay, we have our div container. We'll append a child here, and this is the apod image. So create an image element, specify the source. Of course, you could specify the width, the height, and metadata, alternative text, and stuff like that. In this case, we only need to refresh the page because we haven't changed the service worker. And if we scroll down, this thing did not work. So why is that? Okay, okay, so why did this not work? I'm sorry. It's late already. So of course, best practice would be using this annotation. And so here we go. Here's the image. Of course, this image is much bigger than the container that we specified, and it's of very high quality, so it takes a while. Yeah, so as you can see, our extension does not really serve a maximum use case. It's not really useful, but you've seen a lot of the basic concepts. So we've shown how to actually create the file structure, which you can see here, how to configure the extension and the basic stuff in the manifest JSON, what actually is the background, how to communicate with a front end, which is then in this case our foreground, how to utilize the messaging, how to inject script files as well as CSS, and also dealing with API data a little bit at least, and a little bit of DOM manipulation. So it's pretty much all you need, a basic overview of what you can do and how to do it with Chrome extensions. There's a lot more to come.